Oh, shit. Fire! God. So we can't afford a spot welder, but within our budget we can afford a second-hand microwave, and with the wonders of YouTube, there's a couple of videos out there that create spot welders for batteries out of microwaves. So thank you Facebook Market again, 10 quid. Now the ones on YouTube use Arduino to control the pulse. I have a BBC microbit that will do the job as well. That's the bit we want, right there. This is the magnetron, I think. Yes, it is. It's got a very cool name, magnetron. Oh, is that a massive capacitor? Oh, we could have some fun with that. In any event, focus. That's the bit we want out. So we're going to be getting that out. So what screws?
Interesting. A bit random. I didn't really plan to do this, but I'm kind of interested, and maybe it's kind of inspired you to kind of, you know, work on your own kind of personal.
So the next stage is to cut this secondary coil out, the one that creates all the voltage but no amps, and replace it with a fat coil that creates loads of amps but very little voltage because of the exchange that occurs there. And so this is a bit of a hacksaw job. Let's see how we get on. My fucking favourite of how to get this out. Look. Okay, so it's now solid there. I guess I just knock it out. That's a job for tomorrow. Bring it in. Now this is just a quick test, see if we've got anything going. And I haven't damaged coils and stuff. Oh, there's a hum. Little bit going through there. It's oscillating. So let's touch one with the other and see if we've got any power. Okay. Yep. Plenty of sparks there. Right, let's isolate it and get a safety switch on it. So this is a quick look at the circuitry I'm going to use to control my my little welder. Firstly, at the top here you've got an AC circuit, which is the power is directed via the solid state relay, and that's switched on and off by my microbit. You'll notice the TP31C in there. That's just a switch because the microbit doesn't push out enough power in order to fire the relay. So I'm just using it to fire a small switch and then obviously direct the 8 volts that way into it, enough power to get it to go. And the fire button is there detected by the microbit in order to do that. So let's have a little look at the code that goes on inside the microbit. basically I've created two images, one battery, one arc, and I have two modes in my system that allow me to control the timings of the amount of power that goes through the transformer. So the first one is battery, and that basically just pushes out 220 milliseconds of power and then shuts off, whereas the arc mode provides continuous power until I release the button. So the first bit of it just sets up my basic default settings. One is the mode is battery, cycle 2, and turn the pin on that says that the LED is ready to go, and then it starts the main loop here. Okay, so the first bit is am I pressing a button to change the mode? And if I am, then this bit of code here deals with that. The second one is if I'm in mode battery, this bit ups and increases or decreases the cycles. So actually it gives me in battery mode settings between 180 milliseconds and 260 milliseconds, and defaults to 220 milliseconds. So if I've got a bit thinner metal and I don't want to burn it, I can drop the amount of time the power goes through the system. Here's the battery mode code here, and all it does is it says, okay, if pin 0 is touched, then turn on the relay for 220 milliseconds and then turn it off again, and in the meantime turn off the ready light and then turn it back on once you're done. The arc weld is very similar, except it just says keep firing until the button is released, and that's it. Let's return to our setup. Okay, I've put the first circuit in place. It's all wired up, except the microbit and all that on the relay is not ready. So I'm going to check this circuit first, see if we get the hum. Hopefully we do. There's my master switch. Power on. Okay, let's fire the relay and see if we get a hum. Oh, lovely. Brilliant. Right. Just going to shove a little bit of flux to help the solder. That's brilliant. Okay, that's much better than the first effort, but we live and learn. Right, okay, let's just let that cool a bit. Let's just take those crimps off. Jesus, they're really hot. Right, end of that. Okay, let's fire this puppy up. My switch is off. Yep. Ooh. Going live. Press the button. Listen to that. Okay, so mode. Oh, check it out! Right, switch modes again. Obviously, that's a bit much. So let's go to 2, which is 10 milliseconds on. Oh Christ, it's burning everything underneath. So I've been playing with the settings and moving steadily upwards until we have a proper weld using this the nickel, and this is where we got to. So if I just take that, so during the testing and all that, I got that done. That was done manually on the timing, and I've worked out it's about 220 milliseconds. So here we go, 220 milliseconds, power on. Here we go. There you go. And again. Enough. Oh, ow. Gets a bit warm. There you go. good solid weld. Perfect. Got myself a spot welder for building batteries. Right, let's build a battery. Thanks for watching.